What makes a place terrifying? Is it fire, pressure, darkness, or the quiet realization that the universe was never built with us in mind? For most of human history, the night sky looked almost gentle, a map of lights, a ceiling of order. We gave names to the wandering planets, traced stories through the stars, and imagined that beyond the reach of our ships and weather, the cosmos might simply be a grander version of home. But every generation that looked closer discovered something else. Not chaos exactly, something deeper. A universe of astonishing beauty shaped by forces that do not notice whether we survive them. The modern age of exploration did not begin with footsteps, but with signals. A probe passing a distant moon, a telescope catching a dim object at the edge of sunlight, a dish on Earth listening to a pulse from a dead star. Again and again, the pattern repeated. We reached outward in curiosity and found landscapes that seemed to belong less to life than to physics itself. Oceans of acid, mountains of radiation, worlds without sunrise, regions where gravity bends time so severely that even language begins to fail. And yet the deeper story is not simply that space is dangerous. We already know danger. Storms, deserts, deep water, winter. What unsettles us about these distant places is that they strip away the comforting scale of human experience. They remind us that warmth, breathable air, a steady horizon, even the reliable passage of time are not universal gifts. They are local mercies. So this is not a journey through monsters or myths. It is a journey through real places, documented by science, each one revealing a different edge of reality. Places that challenge not only the body, but the imagination. And perhaps that is the true unease beneath all exploration. When we stare long enough into the universe, we do not just learn what is out there. We learn how rare it is to stand anywhere at all and call it home. What does a world look like when the ground itself cannot decide to stay still? In 1979, Voyager 1 turned its cameras toward a small moon circling Jupiter and caught something no one expected, a plume rising hundreds of miles above the surface. At first, it looked almost like a flaw in the image, a smudge where none should be. Then the truth settled in. Io was erupting. Until that moment, many scientists assumed moons in the outer solar system were old, cold, and quiet, frozen relics. But Io was not quiet at all. It was restless, stained in yellows, reds, and black ash, its skin rewritten again and again by fire from below. More than 400 volcanoes burn there, fed by a strange kind of violence. Jupiter's immense gravity pulls on Io. Neighboring moons tug at it from the side. The entire body flexes, squeezes, and heats from within, as if the moon itself is being kneaded by invisible hands. If you could stand there, the danger would arrive from every direction. Near one vent, temperatures soar hot enough to melt rock. A short distance away, the cold is severe enough to harden gases into frost. Sulfur drifts through the landscape. The crust is thin in places, fragile over deeper turmoil. And above all of it hangs the unseen menace of Jupiter's radiation, intense enough to turn survival into a matter of minutes. Yet Io is not frightening simply because it is lethal. It is unsettling because it overturns our old ideas about what a moon should be. We imagine worlds as stable things, settled into identity. But Io reminds us that some places are still becoming, still breaking and remaking themselves in full view of the stars. Maybe that is why it lingers in the mind, not as a symbol of evil, but as a lesson. Creation and destruction are sometimes the same fire, seen from different distances. How cold can a place become before the idea of survival loses all meaning? Far beyond the warmth of Earth, past the familiar orbits that once defined the edge of the known world, lies a moon wrapped in ice and silence. Triton, the largest moon of Neptune, drifts through a region where sunlight has grown thin and weak, more memory than illumination. Seen from a distance, it appears pale and calm, a quiet sphere suspended in deep blue darkness. But calm in the universe is not always the same as mercy. When Voyager 2 passed by in 1989, it found a surface that seemed almost unreal. Frozen plains stretched outward like the beds of vanished seas. Dark streaks marked the ice where something beneath had broken through. And there, against every expectation, were geysers, thin eruptions of nitrogen gas rising from a world so cold it should have been still. Even here, at temperatures nearing minus 390 degrees Fahrenheit, Triton was not entirely asleep. Its cold is difficult to imagine because it exceeds ordinary human comparison. On Earth, winter still belongs to life. Breath hangs in the air, snow bends under footsteps, and somewhere nearby there is shelter, warmth, other season waiting. Triton offers none of that. The surface is harder than stone in places, coated in frozen nitrogen, methane, and water ice. The atmosphere is so thin it barely qualifies as one. The horizon would feel endless and empty, as though the world had been drained of sound itself. And yet Triton carries a subtler kind of fascination. It moves backward around Neptune, unlike most large moons, as if it were captured from elsewhere long ago. A wanderer taken prisoner. Its frozen skin may preserve a history older than its current home, a record of migration written in ice. That may be what gives Triton its haunting power. It is not only a place of extreme cold, it is a reminder that even the most distant worlds have stories of displacement, endurance, and change. In the farthest silence, something still remembers motion. And perhaps that is what unsettles us most. The universe can seem frozen, while still quietly in motion beneath the surface. What happens to a world when the sky itself becomes the threat? Venus is often called Earth's twin, but that phrase has always concealed more than it reveals. From a distance, the two planets seem like siblings, similar in size, similar in composition, both born in the same early neighborhood of the sun. Yet one became a cradle for oceans, weather, and memory. The other turned into a warning. Beneath its bright clouds, Venus is a place of crushing force. The atmosphere is so dense that standing on its surface would feel like being buried beneath nearly a mile of ocean. The heat is relentless, high enough to soften metal and destroy machinery built with the best intentions of engineers on Earth. Soviet landers that reached the surface survived only briefly, sending back images of a dim orange landscape before falling silent. Those photographs still feel unsettling, as if they were taken not on another planet, but inside the future of a ruined one. The clouds overhead are made of sulfuric acid. The air is almost entirely carbon dioxide. Winds race through the upper atmosphere, while the surface below remains trapped under a stillness so hot and heavy it barely seems real. There are plains of volcanic rock, broad rises that may once have surged with molten stone, and signs that the planet may still be geologically alive. Venus does not merely reject life as we know it. It overwhelms the conditions that make life possible. And that is why it disturbs us in a different way than distant moons or deep space hazards. Venus is not frightening because it is alien beyond comparison. It is frightening because it is close, familiar in outline, catastrophic in outcome. A nearby example of how small differences in climate, chemistry, and time can lead two worlds toward completely different destinies. So when we look at Venus, we are not only looking outward, we are also looking into a kind of planetary mirror, darkened by heat and cloud. The question it leaves behind is quiet but difficult to ignore. How thin is the line between a world that shelters life and one that seals it away forever? What kind of storm can last for centuries and still not be finished speaking? On Jupiter, weather is no passing inconvenience. It is architecture. Bands of clouds circle the planet in vast, opposing rivers, each one moving with a speed and force that would dwarf the fiercest systems on Earth. And within that endless motion lives a storm so large it has become part of Jupiter's identity, the Great Red Spot, a vortex wide enough to swallow our planet whole. For generations, astronomers watched it through telescopes as a colored oval drifting in the gas giant's southern hemisphere. At first, it was simply a curiosity, a stain on a distant world. But over time, the measurements deepened the mystery. The winds along its edges can exceed 400 miles per hour. The storm rises high above the surrounding cloud tops, turning through layers of ammonia ice and chemical haze. Lightning flashes elsewhere across Jupiter's atmosphere. Pressure intensifies downward into depths no human eye could ever penetrate. There is no solid ground to stand on, no shoreline, no shelter, only descent into thicker darkness. To imagine entering Jupiter is to imagine the disappearance of every human reference point. The sky would not stay above you, because the sky would be everything. The colors would shift from cream and rust to shadow and heat. The deeper you fell, the more the atmosphere would tighten around you, until familiar distinctions, Air and liquid, motion and collapse began to blur. Somewhere below, hydrogen is pressed so intensely that it behaves like metal. Jupiter is less a place one visits than a process one is absorbed into. And still, for all its violence, there is something strangely moving about that red storm. It has endured longer than entire human lifetimes, perhaps longer than some nations and empires. It reminds us that not all tempests are brief. Some become climates, some become history. That may be Jupiter's quiet lesson. We tend to think of storms as interruptions, brief disorders in an otherwise stable world. But in the wider universe, the storm may be the world, and what we call calm may simply be the rare exception that allowed us to appear at all. What if the most dangerous place is not a planet or a moon, but a boundary where even time begins to lose its familiar shape? A black hole does not announce itself with a surface you can land on or a horizon you can measure with ordinary tools. It reveals its presence indirectly, through the motion of nearby stars, through X-rays from matter heated to impossible brightness, through a darkness that appears not empty, but consuming. It is less a destination than a threshold, the point where gravity stops behaving like weather and starts rewriting the rules entirely. Near a black hole, space itself bends inward. Matter caught in its grip forms a glowing disk, spiraling faster and faster as friction and gravity strip it apart. Temperatures rise to extraordinary levels. Radiation floods outward. And then there is the event horizon, that invisible border beyond which no message returns. Cross it, and every path leads deeper in. For an outside observer, time near that edge slows almost to stillness. For the falling traveler, the descent may seem normal at first, which is perhaps the most unsettling detail of all. The danger is not merely impact or heat, it is distortion. Gravity near a black hole is so uneven that it can stretch an object lengthwise and compress it sideways, a process scientists sometimes describe with grim simplicity. But behind the vivid terminology is a deeper discomfort. Black holes confront us with a place where our intuitive understanding of reality begins to fail. Cause and effect remain, but ordinary imagination cannot keep pace. And yet these objects are not monsters placed in the universe for punishment. They are natural outcomes of mass, collapse, and time. They shape galaxies. They influence the birth and motion of stars. Even in their apparent silence, they help organize the larger cosmos. Destruction here is inseparable from structure. Perhaps that is why black holes fascinate us so deeply. They are terrifying, yes, but also clarifying. They remind us that the universe is not obliged to remain understandable at every scale. There are frontiers where knowledge continues, but comfort does not. And maybe that is the truest definition of awe, not the absence of fear, but the willingness to look anyway. What would the sky feel like if a single burst of light could erase a world before it ever understood what had happened? Somewhere in the universe, stars die with such violence that distance becomes the only mercy. These events are called gamma-ray bursts, though the name sounds almost modest compared to the reality. For a few seconds, sometimes minutes, they can release more energy than the sun will produce across its entire lifetime. They are not places in the ordinary sense, but phenomena. Brief corridors of catastrophic power, born from the collapse of massive stars or the collision of compact remnants like neutron stars. If one occurred nearby and its beam happened to sweep across Earth, the danger would not arrive as fire from the horizon. It would come invisibly at the speed of light through the upper atmosphere. Ozone could be stripped away. Radiation chemistry would change the sky before any human eye understood the source. The harm would unfold through systems we depend on but rarely notice: the atmosphere, the climate, the fragile filtering layers that stand between life and the raw universe. That is part of what makes gamma-ray bursts so haunting. They do not fit the old human template of disaster. There is no tremor underfoot, no storm cloud gathering offshore, no mountain beginning to smoke. They remind us that some threats are too large, too distant, and too swift for instinct to interpret. By the time we could name them, their work would already be done. And still, these bursts are not merely symbols of destruction. They are also signals. Astronomers study them as beacons from the far universe, clues to the life cycles of stars in the history of galaxies. In their brief flare, they illuminate processes otherwise hidden by scale and time. Even catastrophe, viewed from far enough away, becomes a form of information. That may be the difficult wisdom here. The universe does not separate beauty from danger in the way we often do. The brightest thing in the sky may also be the most merciless. Yet we keep watching, keep measuring, keep learning from flashes that could never welcome us. Perhaps that is what maturity in science really looks like. Not conquering the cosmos, but learning how to read its most violent sentences without pretending they were written for us. What if a star could survive death, but only by becoming something almost too dense to imagine? A neutron star is what remains after a massive star has collapsed and exploded, shedding its outer layers in one final act of brilliance. What is left behind is not a quiet ember, but an object of astonishing compression. A mass greater than the sun can be packed into a sphere no wider than a city. Matter there is pressed so tightly that the ordinary structure of atoms gives way. Electrons and protons merge. Space is no longer empty between things. It is burdened. From a distance, a neutron star may seem almost abstract, more equation than object. But its effects are real and severe. Gravity at its surface is immense. Magnetic fields can be trillions of times stronger than Earth's, powerful enough to distort atoms and drive violent bursts of radiation into surrounding space. Some neutron stars spin with breathtaking speed, turning dozens or even hundreds of times each second, sending out pulses so regular that early researchers briefly wondered if they were hearing signals from intelligence rather than nature. The truth was stranger and more elegant, a dead star still speaking. To approach such a place would be to enter a realm where common sense fails quietly. A pebble-sized piece of neutron star material, if it could somehow be removed, would weigh more than mountains. A misstep is not even the right metaphor, because there is no walking there, no standing, no human scale left intact. Everything familiar, weight, pressure, solidity, has been driven past its ordinary meaning. And yet neutron stars are not only warnings, they are records of transformation. They tell us that endings in the universe are often forms of compression rather than disappearance. A star does not simply vanish. It changes state, condensing history into a smaller and more intense form. Something similar may happen in memory. Time passes, events fall away, and what remains can grow denser, heavier, more charged than the life from which it came. Perhaps that is why neutron stars feel so deeply human, despite their strangeness. They suggest that survival is not always softness or continuity. Sometimes it is pressure endured. Sometimes it is a pulse carried forward through the dark, steady enough for someone far away to notice. What kind of place can tear apart not just a spacecraft, but the very idea of direction? At the center of our galaxy lies a region crowded with stars, dust, radio waves, and unanswered questions. Hidden there behind veils of Gaussian distance is Sagittarius Oak, the supermassive black hole around which the Milky Way slowly turns. We do not see it directly in the ordinary sense. We infer it through the dance of nearby stars, each one circling an invisible mass with extraordinary speed, as though obeying a conductor no eye can meet. The environment around the galactic center is not empty darkness. It is crowded, turbulent, and intense. Stars pass close together. Magnetic fields twist through clouds of hot plasma. Radiation pulses through the region. Matter drawn inward accelerates, heats, and glows before vanishing beyond recovery. This is not the clean isolation of a laboratory thought experiment. It is a living crossroads of gravity and motion, where vast structures are organized around something that cannot be approached without consequence. For a human mind, the danger begins even before the physics. We are used to landscapes that orient us, a horizon, a sunrise, a north and south. Near a supermassive black hole, those familiar anchors grow unreliable. Light bends, distances deceive. Time itself no longer flows with the reassuring sameness we take for granted on Earth. The closer one imagines moving toward that central abyss, the more reality seems to lose its ordinary grammar. And yet the galactic center is not merely a zone of threat. It is also a source of coherence. Its gravity helps shape the movement of stars across immense spans of time. What appears destructive at one scale becomes organizing at another. In this way, Sagittarius A stands as one of the universe's more difficult truths. Some centers hold things together precisely because they are dangerous to approach. That idea reaches beyond astronomy. In human life, too, there are forces that organize us while remaining impossible to touch directly. Memory, loss, longing, history. We orbit them. We measure ourselves against their pull. And perhaps that is why the center of the galaxy feels strangely intimate. It reminds us that not everything important can be safely visited. Some truths can only be understood by the paths they cause us to take around them. What happens when a star does not explode or collapse all at once, but slowly turns into a trap for anything that comes too close? There are stars in the universe that live ordinary lives by cosmic standards, burning steadily for ages beyond human comprehension. And then there are stars that seem to exist at the edge of restraint, unstable, massive, and fierce enough to make their surroundings feel less like a solar system and more like a warning. Among them are magnetars, rare remnants of stellar death whose magnetic fields are so extreme that they challenge language itself. A magnetar is a kind of neutron star, but to call it that almost feels incomplete. Its magnetic field is not simply strong, it is overwhelming. At a distance, it can disrupt electronics. Closer in, it can deform the structure of atoms, altering the behavior of matter in ways no human body could endure. Bursts from its surface can flood space with high-energy radiation. Starquakes, or fractures in its ultra-dense crust, can send ripples of energy outward across the galaxy. For a brief moment, an event on a magnetar can disturb instruments on Earth, despite the impossible gulf between us. This is a different kind of terror than fire or gravity alone. It is the terror of invisibility. Magnetism has no color, no sound, no face. We know it through consequence. A compass turning, a current induced, a machine failing. Near a magnetar, consequence becomes everything. The body, the ship, the instruments meant to explain the place. All would be compromised before any traveler could form a clear impression of what was happening. And still, even here, the story is not only about destruction. Magnetars reveal how much of the universe operates through forces we cannot see directly. Their violence is a reminder that reality extends far beyond the limits of our senses. We live by translated signals, by measurements turned into understanding, by trust in patterns our bodies were never designed to perceive. Perhaps that is the quiet lesson of a magnetar. The universe is not only made of visible wonders, rings, storms, and shining clouds, but of hidden structures that shape everything while remaining unseen. And maybe maturity, in science as in life, begins when we accept that some of the strongest forces we will ever encounter are the ones we cannot look at directly, only learn to recognize by the changes they leave behind. What would it mean to fall into a place where the universe itself is still unfinished? Long before planets cooled and oceans gathered, before mountains, forests, or memory, the early universe was a harsher country. It was hotter, denser, more turbulent, a reality still assembling its own laws into something stable enough for stars and galaxies to endure. When astronomers look across immense distances, they are also looking backward in time, into eras when matter and light were locked in a more violent conversation. And in those ancient intervals, there were regions no human being could ever have survived, not because they were malicious, but because existence itself had not yet become hospitable. The young universe was filled with searing radiation and a heat beyond ordinary imagination. Particles collided constantly. Space expanded rapidly, carrying the seeds of future structure outward in every direction. There were no solid worlds, no breathable skies, no calm nights beneath a scattering of stars. The cosmos, in its earliest chapters, was a furnace of possibility. Everything that would later become familiar, atoms, galaxies, the chemistry of life, had to emerge from that pressure first. This kind of danger is difficult to picture because it lacks the shape of a landscape. There is no cliff to avoid, no storm cloud to outrun. The hazard is total environment. To exist there as a human would be impossible, because human is exactly the sort of fragile arrangement that had not yet become thinkable. The early universe is terrifying in the way deep origins often are. It reminds us that life is not the default condition of reality. It is a late achievement, and yet there is something deeply moving in that realization. From those unbearable beginnings came everything we know: the iron in blood, the calcium in bone, the oxygen in breath, All of it traces back to a universe once too fierce to welcome any witness. What now feels intimate was forged in conditions that would destroy us instantly. Perhaps that is the real wonder. The places most hostile to life are often the places that made life possible in the first place. We are not separate from that ancient violence. We are its refined aftermath, its quieter inheritance. And maybe every act of looking back is also an act of gratitude for the long, improbable cooling that turned a universe of raw force into a world where someone could finally ask how it all began. What if the most uninhabitable places are not distant at all, but hidden inside stars we have spent centuries admiring? The sun, from Earth, feels gentle enough to be symbolic. It lights kitchens and sidewalks, falls across old photographs, warms skin on a winter afternoon. We have written poems to it, scheduled our days around it, trusted its return without much thought. But that calm familiarity exists only because of distance. Up close, the sun is not comfort. It is pressure, violence, and continuous nuclear fire. Its surface, if that word can even be used, is a churning boundary of plasma. Great loops of magnetized gas rise and fall across it like luminous architecture in motion. Solar flares erupt with startling force. Coronal mass ejections hurl charged particles across space. Beneath that visible layer lies a deeper reality, a crushing interior where hydrogen nuclei are forced together until they fuse, releasing the energy that eventually reaches our world as warmth and light. The process seems serene from 93 million miles away. At the source, it is relentless beyond comprehension. No human craft could descend meaningfully into such a place and remain itself. Heat would not merely burn, matter would come apart, structure would fail. Even the categories we rely on, solid, liquid, gas, become unstable in a star's body. The sun is not a place for landing, standing, or surviving. It is a sustained reaction, a vast equilibrium maintained by opposing immensities, gravity pulling inward, fusion pressing outward. And still, the star that could erase us without effort is also the one that made our existence possible. That paradox may be why the sun deserves a place in this journey. It is not frightening in the way of a hidden abyss or a remote storm. It is frightening because it reveals how dependence and danger can be inseparable. The same force that nourishes every leaf and living cell on Earth is, in itself, utterly beyond mercy. Perhaps that is a mature way of seeing the universe, not as divided between friendly things and hostile ones, but as a web of conditions in which life emerges through careful distance, timing, and balance. The sun is not our enemy. It is our reminder that what sustains us most deeply is not always something we can approach. Some gifts only remain gifts when held at exactly the right distance. What if the deepest danger in the universe is not fire or cold, but emptiness so complete that it slowly undoes every connection? Between galaxies lie distances so vast they resist feeling. Light crosses them, but only with patience measured in millions of years. In those enormous intervals are cosmic voids, regions where matter is scarce and structure thins almost to nothing. They are not truly empty, but compared with the crowded brilliance of galaxies, they come close. If stars are the universe speaking in bright sentences, voids are the long silences between them. A traveler crossing such a region would not face a storm in the ordinary sense. There would be no crashing waves of radiation, no volcanic ground, no visible predator in the dark. The threat would be subtler and in some ways more profound. There would be almost nothing to navigate by. Few nearby stars, few landmarks. Little sense of movement except the slow drift of instruments and the inward turning of thought. Human beings are not built only for oxygen and warmth. We are built for reference points, for orientation, for the reassurance that somewhere something answers back. That is why cosmic emptiness carries a special kind of fear. It suggests a universe in which one could continue existing while becoming steadily less connected to place, to time, even to meaning. The body might endure longer than the spirit. Isolation would cease to feel like a condition and start to feel like a law of nature. Out there, survival would not be a matter of bravery alone. It would be a matter of retaining coherence in a setting that offers almost none. And yet the void also has something to teach. It reveals that the universe is not made only of spectacular objects, but of spacing. Absence gives shape to presence. Silence frames sound. The great empty regions help define the cosmic web by surrounding it. Even nothingness participates in structure. Perhaps that is why the void feels less like a monster than a question. How much emptiness can a mind endure before it begins to invent its own constellations? Maybe the answer is deeply human. We survive not only by finding worlds, but by making meaning between them. In the longest silence, the search itself becomes a kind of light. After all these places, burning moons, frozen exiles, crushing atmospheres, immortal storms, collapsing stars, and the vast grammar of emptiness, we arrive at a quieter question. Why do we keep looking? Why map worlds that would kill us instantly? Why measure the temperature of infernos, the pull of invisible abysses, the radiation of dead stars, when none of them were made for human feet? Part of the answer is practical. To understand the universe is to understand the conditions that shaped our own existence. Every hostile world clarifies something about Earth. Every extreme teaches us where the boundaries are, how atmospheres fail, how climates run away, how gravity distorts, how stars live in time, how fragile the shelter around us really is. Knowledge in that sense is not escape from life. It is a deeper return to it. But there is another answer harder to quantify. We look because wonder is one of the most human instincts we possess. Not the shallow thrill of shock, but the older and steadier urge to place ourselves within a larger story. The universe humbles us, yes, but it also enlarges us. It asks us to think beyond the scale of one lifetime, one nation, one generation. It reminds us that the elements in our bones were forged in ancient stars, that the light entering our eyes tonight may have begun its journey before human history had a name. The most terrifying places in the universe, then, are not only warnings. They are mirrors held at an impossible distance. In their violence, we see the rarity of tenderness. In their silence, we hear how precious consciousness is. In their indifference, we discover the meaning we create for one another here on a small world with air thin enough to breathe and gravity gentle enough to bear our weight. Perhaps that is the final insight hidden inside all this danger. The cosmos does not owe us comfort, and yet comfort exists. It does not promise memory, and yet we remember. Against cold, fire, pressure, darkness, and time, human beings go on telling stories, asking questions, and reaching outward. And maybe that is our true place in the universe, not at its center, not beyond its laws, but within it, briefly and beautifully aware.